Hello, in this video we're going to look at more features of functions. The first feature we're going to consider is where a function is positive. The definition for positive refers to the intervals where the y-coordinates are positive or above the x-axis. And the mathematical way we can note this is by writing f of x is greater than 0. We say a function is negative when the coordinates are below the x-axis, and we write this as f of x is less than 0. To write our answer for either a positive or negative interval, we need to always use the x values. And the reason is we already know that the function y values are positive or negative, so our intervals are going to only use the x values. Another important thing to keep in mind is that at the x-intercept, f of x is equal to 0, so that the x-intercept should not be included in either of the positive or negative interval features, and this means that my intervals should never include brackets. Since I will use the x values in my intervals, I will read the graph the left to right. Now let's consider this example and where the function is positive and negative depending if it's below or above the x-axis. So looking from the most left part of the graph, I see that as x is coming from negative infinity, the graph is below the x-axis, so it is negative, and it continues being negative until we reach the first x-intercept at -3. So our first negative interval is from negative infinity to -3. Notice I am using parentheses since at 3, the graph is 0, the f of x is 0, therefore it is not negative and should not be included in the interval. The next section of the graph is above the x-axis, so we would say that that's the first positive interval from -3 to 1. Now, if we look at the graph, we can see that the graph dips underneath the x-axis 2 more times, so we have 2 more negative intervals, and those intervals go from -1 to 1, that's our middle interval, and the last interval is going from 4, and it keeps on going to the right, so that would make my x value infinity. And since there's multiple intervals, I will use the U symbol, which stands for union, and you want to use whenever there's multiple intervals that you want to list out. And there is one more positive interval from 1 to 4, so I will use the union again to show that there's another interval that's positive from 1 to 4. And that's all you need to do for positive and negative intervals. We're going to consider 4 more features of functions that all fall under the category of extremas, and that's because they're going to be extreme features. So the first one we're going to consider is an absolute maximum, and an absolute maximum is just the absolute highest point on a graph, and it should look like the highest point on a mountain. The absolute minimum is going to be the absolute lowest point on a graph, and it should look like the bottom of a valley. The relative minimum is an highest point in a section of the graph, but not in the entire graph, while the relative minimum is the low point in a section of a graph, but not in the entire graph. So looking at this graph, we can see that 2.935, 4.813 is the absolute highest point. Therefore, it is my absolute maximum. However, -2.224, 1.906 also looks like a high point, but it only looks like a high point in this region of the graph, not in the entire graph. So then we would say 2.224, 1.906 is a relative maximum. Now, since the graph has arrows pointing down, there's no actual absolute minimum value because we can never reach negative infinity. There's no absolute minimum point. Now, if we look in this section of the graph, though, we can see that 0, -1.2 looks like a minimum, since it's a low point in this section of the graph, but we know it's not the absolute minimum, so we would say 0, -1.2 is a relative minimum. The last 2 features we're going to consider in this video are increasing and decreasing. And the definition for increasing is that as the x values are increasing, the y values are increasing. The definition for decreasing starts the same because we say as the x values are increasing, and this just means that we're reading the graph for both of them, left to right. What are the y values doing? Well, with increasing, the y values should be increasing, and with decreasing, the y values should be decreasing. Now, since I already know what the y values are doing, they're either increasing or decreasing, I'm going to use the x values to write these intervals. So looking at the graph, starting on the left, because I'm looking as x values are increasing, I see that the graph is going up. Also, the y values are increasing. And at this point that I've stopped at negative 2.224, 1.906, the graph stops increasing and it just is in neutral. So this interval should be from negative infinity to negative 2.224, and I'm going to use the parentheses because I can't increase or decrease at the same time, so we will never use brackets in our interval, so we would only use parentheses. Now looking at the graph, I can tell that there's one more increasing section from 0 to 2.935, and just like before, since there's two intervals, I'm going to use the U for union sign. And my two intervals where the function is decreasing, I'm going to color them in, and you can see there's two of them from negative 2.224 to 0, and union sign from 2.935, and it keeps decreasing going to the right. So even though it's decreasing, I'm writing the x values, and the x values are going to the right, so it keeps decreasing all the way to infinity. And that's it for increasing and decreasing. Consider this extra practice problem and try answering these questions. Do your best approximating the x-intercepts and use them for the following intervals. These are my x-intercepts that I've approximated. And to show that this is a list of points, I'm going to put commas between them. Using these values, determine where the function is positive. And to show that all of these are positive intervals, I will use U between them because they're intervals, not points. Where is the function negative? To determine where the function is increasing or decreasing, I'm going to have to figure out my extremas, as those will help me figure out the intervals. Using these points, let's determine where my function is increasing and where it's decreasing.